Assalamu alaikum dear students, I am Engineer Abdul Basit and we are in week number 3, lecture number 6. Okay, so this is particularly the second lecture of this week. Okay, uh, the topic we were discussing in the previous lecture was Newton's law of viscosity. Okay, so this lecture is actually continuation of that particular lecture. Okay, in this lecture we will discuss about the kinematic viscosity, the dynamic viscosity, and we will solve some simple numericals on this on those equations for kinematic and dynamic viscosities. Okay, so let's start the lecture. First of all, what does it mean by kinematic viscosity? Okay, simply, uh, as I mentioned earlier in the previous lecture, or you can say in the first slide of that previous lecture, that is, viscosity is actually a resistance to the flow of liquid, a resistance to a change in shape of the fluid. Okay, but density is mass per unit volume. Okay, so why I was explaining that term, that viscosity shouldn't be confused with the density, because some liquids may have a greater viscosity but lesser density. Some liquids may have greater viscosity and greater densities as well. Okay, so that cases may be related to each other. That viscosity and density terms may not be related to each other, may be directly proportional, may be inversely proportional. So uh, to solve that confusion, or to get rid of that confusion, we have to discuss a new type of viscosity, that is kinematic viscosity, which is giving us a relationship between the viscosity and the density. Okay, so this will be that perfect term for us to discuss the that term of viscosity and density relationship. Okay, to specifically and clearly discuss the term of viscosity. So that kinematic viscosity is particularly represented by V and the small v, and that is mu divided by density. So if we have any type of liquid, that may be water, maybe honey, maybe any oil, petrol, etc. Okay, so that absolute viscosity divided by that density is actually called kinematic viscosity. So this is that mathematical form. Okay, the statement should be like that: a kinematic viscosity is actually a type of viscosity which covers both the absolute viscosities and density of a liquid under a single term, that is kinematic viscosity. Okay, so here it is. It is convenient to use a modified form of viscosity. Thus, a new term, kinematic viscosity, was coined, which is the ratio of absolute viscosity, that is in Newton seconds per meter square, to the density of the liquid in kg per meter cube. Okay, as we know that the unit of density is kg per meter cube, because it is mass per unit volume. So mass is in kgs and volume is in meter cube. Okay, while the viscosity will be in the same units, that is Newton seconds per meter square, and we have derived this unit in the previous tutorial as well. So that kinematic viscosity will become like this. If you want to go further in the details for units, so then this mu is actually equal to mass per unit length per unit time. Okay, so why it is so? Because mass is actually this Newton is equal to F is equal to ma. Okay, that second law of the second law of motion, Newton's second law of motion. So from that you can find out what Newton's is actually equal to, and by putting the values you will get this type of dimension for that. So that will be mlt divided by that density is having the dimensions m divided by l cube. This is mass, this is distance, so you can see it from here. Okay, so then by solving this equation and by crossing the nominators with denominators, so you will get this L square divided by T, which is m square meter square per second. Okay, so this will be the new unit for the kinematic viscosity. Okay. In other words, you can say SI systems has no specific unit for kinematic viscosity, but a bit modified form is used as stock, and stock is actually equal to 10 raised to power minus 3 meters square per second. So you can say divided by 10,000. Okay, 1 divided by 10,000 multiplied by meter square per second. Okay, so you can say the 10,000 part of a meter square per second is actually equal to stock. In other words, you can say stock is particularly a small unit. Poise is also a small unit. Okay, so poise is a unit for uh, absolute viscosity, while stock is a unit for kinematic viscosity. Okay, so this is 1 divided by 1000 meter, 10,000 meters square per second. Okay, you can say this small unit can also be used as centistock, which is actually 1 divided by 100th of a stock. Okay, so the 100 part of a stock is actually centistock. Okay, effect of temperature on kinematic viscosity. So here it is a table that shows us when the temperature is increasing, okay, the kinematic viscosity is decreasing. As the density will change, the density will increase. Okay, so you can say the density is in nominators and denominators, so that's why this term is getting decreased with increase in temperature, or this term will as this term is the density is increasing, this term will get on increasing. Okay, so you can say for 100 degrees centigrade we are having the least kinematic viscosity, okay, in stocks, and for 0 degrees centigrade we are having maximum kinematic viscosity in stocks. Okay, so here is a simple numerical on this equations we have provided in the previous slide, these equations. Okay, so coming to the numerical directly, find the kinematic viscosity of an oil in stocks. Okay, so whose specific gravity is 0.95 and viscosity is 0.011 poise. Okay, so this is specific gravity given over here, and for kinematic viscosity we need to find out mu and density. So as we are given with the specific gravity, so from specific gravity we can find out the density of that particular fluid. So this is an oil. How to do it? Let me draw it for you. That the specific gravity, that is, let's say G, will be equal to density of oil. Let's say this is oil. Okay, that will be divided by density of water. This is raw I'm trying to draw. Okay, so this is density of water. So if you want to find out density of oil, so simple it is density of oil will be equal to that G specific gravity multiplied by density of water. Okay, so from here you can see this density, this is the specific gravity multiplied by density of water will be equal to density of oil. Okay, here it is. So this will be the density of oil for which you want to find out the viscosity or kinematic viscosity, and viscosity is given in poise. Okay, if you want to convert it to the to another unit, that is Newton seconds per meter, so you have to divide this by 10. Okay, so this will be the new form in Newton seconds per meter square. Putting all these values over here, okay, you will get this thing, that is in the form of 10 raised to power minus 4. Okay, so if you remove this 10 raised to power minus 4, so the unit will be converted to stock as we have discussed here. Okay, so this will be 0.0116 stocks is the answer. Okay, so very simple thing. In the second numerical, that is the space between two parallel square plates, each of sides 0.8 meters, is filled with an oil of specific gravity 0.8. So again, specific gravity of oil is given, and the two parallel square plates each side is given. Okay, so from this we can find out the area as well. Okay, the The space between these two plates is 12.5 meters, and the upper plate, which moves with a velocity of this much, requires a force of this much. Determine the dynamic viscosity of oil in poise and kinematic viscosity in stocks. So here all the data is given. Now you have to find out the dynamic viscosity as well and the kinematic viscosity. Okay, absolute viscosity and dynamic viscosity actually refers to the same thing. Okay, so first of all, how to find out that dynamic viscosity, kinematic viscosity. The first thing is dynamic viscosity. We need to find out dynamic viscosity first. First of all, adjust these units accordingly. Each square is having one side length 0.8, specific gravity is given 0.8, y is given 12.5. Okay, so convert it to meters, this will be the thing, and velocity is given in meter per second, force is given in that is 51.2. so from this force you can find out the tau for yourself. Okay, how to find out tau? Force per unit area. From here to get this area, one side is given 0.8, so multiplying 0.8 and 0.8 you will get the area. Okay, so this tau will be determined to you, and then you will find out the viscosity as well. So here it is, dynamic viscosity need to determine. Area will be equal to 0.8, one side is 0.8, other is 0.8, it is a square plate, so this will be the area of the layer. Okay, and tau is force per unit area, so force is given, area is determined. Okay, so this will be like 80 Newton per meter square. So to the shear stress tau will be equal to, tau is equal to mu multiplied by v divided by y. Okay, so from here if you want to find out mu, so take it to one side, and this will be like mu is equal to this thing. Okay, dividing it by 10 by you need to divide it by 10, not by 100. Okay, this will be 8 Newton seconds per meter square. Okay, this will be poise, this will be now in poise. Okay, so here, okay, this is the requirement of the equation, so no need to adjust it. Here it is multiplied with time with 10, multiplied it with 10, so to convert it to poise. Okay, kinematic viscosity of oil in stocks will be equal to, densities need to be determined, specific gravity is given, multiply it with the density of water, so you will get density of the oil. Okay, and this dynamic viscosity is given to us, and density is determined over here. Okay, then putting the values you will get the same thing, that is this is 10 multiplied by 10 is to power minus 4 meters square per second. So as I told you earlier and explained the previous problem, that removing this 10 raised to power minus 4, the unit will be converted to stocks. So this is 10 stocks is the answer for kinematic viscosity. Okay, so dynamic viscosity and absolute viscosity are actually the same terms. Okay, but kinematic viscosity is something different, which is that mu divided by rho, that dynamic viscosity divided by density. Okay, so that's all about this lecture. Inshallah, in the next week we will discuss about types of fluid: ideal fluid, real fluid, Newtonian fluid, and non-Newtonian fluids, and we will also try to discuss different types of pressures. Okay, so that's all. Thank you very much.